Hello, everyone, and thanks for joining us for today's presentation of the Yaskawa webinar series. I'm Greg Smith. I'm a member of the marketing team here at Yaskawa Motoman in Miamisburg, Ohio. For those of us joining us for the first time, we present product spotlights, emerging technology, how-to webinars about every 2 weeks on average. Just a couple of announcements before we get started. Everyone who registered will get an email with a replay link and a link to our webinar archive on our website. If you have questions at any time or experiencing any trouble, use the chat console on the right side of the screen. I have a colleague standing by to assist with any of those. If you have any questions, we will address those at the conclusion of the presentation. Today's topic is Intelligent Robotics in the Modern Supply Chain, presented by Josh Clower. Josh is the Director of Sales at Motoman, and today he'll be talking about Motoman and use cases for intelligent robotics in distribution and fulfillment operations. So Josh, we appreciate you spending some time with us today. We know things are getting kind of crazy with the trade show season spinning up, but I'd like to welcome you, and you can go ahead at any time.
Thank you, Greg. We really just want to thank Yaskawa here for giving us the opportunity to talk about how we see intelligent robotics playing a role in the modern supply chain. Again, I'm Josh Clower from Motoman Corp here in the U.S., and I'm the Director of Sales. So let me jump into the agenda here. I'm going to turn my camera off so that we can go full screen. But great, thanks for coming into the webinar here. Okay, so today we're going to kick it off with a little introduction to Motoman. We're an intelligent robotics company, just really starting up here in the United States to bring some of the technology that we've developed over the last decade in Asia to the North American market, and we'll introduce you to our technology and who we are as a company. Then we'll go into what is the current state of distribution and fulfillment. What are the market conditions? What are the recent impacts? We'll talk a little bit about COVID-19 and how it's impacted distribution, logistics, fulfillment. And then really answer the question, why should you implement robotics now? What are the benefits of robotics? Where is the state of adoption within logistics operations? And what are some of the key enablers that are allowing companies to use robotics in new ways and in better ways? And then we'll wrap up with what are some of the use cases for intelligent robotics. So that's the main focus, and then at the end we'll have some Q&A. So Motoman was founded back in 2011. So we've actually just passed our 10-year anniversary. So we are a fairly long history in this space of intelligent robotics. And that really comes back to our two founders. So our founders are up there on the upper right. On the left is Issei Takino, who is the CEO. Issei was born in Japan and really is our market knowledge expert in Japan. He has a long and award-winning career in technical solution sales within the manufacturing space. And he's really given us a great competitive advantage in the market in Japan, and also creating, really building relationships with the robot OEMs that are in Japan. Our other co-founder, Ross, on the right there, Ross Tienkov, he is the CTO of Motoman and co-founder. He grew up in the U.S. and actually went to UC Berkeley and then went on to do his PhD. He got a PhD from the Robotics Institute at Carnegie Mellon, where he did a thesis in the automated construction of robotic manipulation. So he is really the brain behind the operation here in terms of the technology, and a lot of what he's done in college and just outside of getting his PhD has translated into what now is Motoman technology. So he did a stint right after the PhD at Willow Garage. If you're familiar with Willow Garage, it's out in California, and really a group that innovated on control of robotics, did a lot with the robot operating system ROS, and really out of Willow Garage came many companies. Fetch out of California is one of them with Melanie Wise, and coming out of Willow Garage, he was developing solutions, developing robotic technologies that were used in research and used in a large variety of ways. But he really found that he had a passion for trying to create solutions for the industrial space. And that's what led him to Japan, where he first met Issei. And that's where really how Mugen started, is the meeting of these two guys on the upper right. And they decided to start the company in Japan because it's a great, it's really been a great crucible for us. There's a large appetite for automation in Japan because of the aging workforce, but there's also a very high expectation that's really been set by some of the automakers. Toyota Production Systems comes to mind, where there's really a high expectation for what the automation does and how effective it is and how reliable it is. And in addition to the appetite and the expectations of the market, there's also a large amount of robot OEMs, Yaskawa being one of them, that we've created relationships with to learn more about robotics and how we can help and what gaps we can fill to advance the robotics cause in general. So it's been a great launch pad for us. And then we're getting started in the US here. We also have offices in China. And over the years, we've acquired some of the greatest minds in software development and robotics control, and an integration of these technologies within the industry from many different companies and many different top institutions across the globe. So we have a very diverse group in Japan with 25 plus nationalities and over 160 employees to date. In addition to the employees, and we're in China, Japan, and now the US, we've acquired a lot of IP, intellectual property, along the way. And also we've been highly regarded in Japan for the work that we've done to innovate within the robotics space. So we've won many awards for innovation and been recognized by institution and third-party associations and the Japanese government actually as well. And we've deployed over 600 intelligent robotic systems, primarily in the Asian market, in Japan and China. And now we are bringing this experience to the United States. So that's who Mugen is. Let's talk a little bit about what is our technology. What do we do? And Mugen makes any robot more capable, efficient, and reliable. And the way that it does this is it uses a model-based definition of the world and adds sensory data to that model and creates a motion plan for the robot. So there's some auxiliary pieces of technology with machine vision. So we've partnered with some of the state-of-the-art machine vision, 3D vision, perception companies in the world to create and really help them better their products and help us create solutions for the applications that we've focused on within logistics and manufacturing to create the perception of the work pieces and the perception of the destination areas. Maybe it's a pallet, maybe it's a tote, whatever we're putting the work piece in or potentially picking the work piece out of. And then in addition to the vision side of things, we also have some very versatile end-of-arm tooling. So we have a lot of gripping technology, which is grasping of the work piece is a very critical component to creating an intelligent robotic solution. So by combining the vision, force torque sensing on the grasping, and sensory feedback on the vacuum, sensory feedback on the mechanical grippers that we have as well, and automatic calibration within the scene on the gripper as well. By combining these perception technologies with our model-based approach for the control technology, we have a very reliable and efficient system. So the core technology really is the Mugen controller, which is what you see there on the right. And it is really a combination of controlling and reading from these perception auxiliary pieces, creating that model-based definition of the work cell. And that model is not just, the dimensions of everything within the work cell, a CAD drawing, if you will, but it's also kind of the physics engine behind what do each one of those components do. Is it, if it's a conveyor, then how does it move? If for the gripper, each individual cup, how does it react and have real-time feedback on that within this physics engine? And it's really ultimately that combined with our motion planning software really creates a digital twin within the Mugen controller, so that when when our robots are operating, they're operating synchronously with the simulation environment on the pendant. So the big value there is that you don't actually have to program these robots. There's no coding involved. They're teachless. So you essentially set up the model of the environment to give some parameters about what's the source and where are you picking from and where are you going to, what's the destination, and what type of application is it. And then the algorithms that run behind the scenes within the Mugen controller are capable of automatically developing a motion plan in real time, so that you're not telling the robot how to move. We control the robot arm at the servo amplifier level and tell the robot arm exactly how to move and also how to interact with the work pieces and the different obstacles that are in the environment. Like if you're dropping into a cart, what do the walls look like? Have they been deformed from damage within the warehouse? And do we need to move around that damage, or is it greater than a certain threshold, and we need to call an operator and tell them to take it out of the workflow? So there's a lot of intelligent components to how we move within space, but also a lot of data on how are we interacting with the work pieces and the environment itself. And all of this is stored and can be shared via the controller to your execution systems, your ERP systems, your WMS systems, so that you have perfect traceability in what's going on within the environment. And the controller itself is actually an industrial piece of hardware. It's got the ISO rated functional safety on board, so you can actually wire in your safety fence directly to the controller. It's got digital I/O. It's got Ethernet for communication to the PLC level, the warehouse level automation systems, the material handling equipment, but also up to the business level systems with the WMS and the WESs and WMSs of your warehouse. So in a nutshell, that's our technology. We know that this brings a lot of value to the logistics space, and it really opens up new applications within the logistics market. So let's take a step back. So that was an introduction to Mugen. Let's talk a little bit about what is the current state of distribution and fulfillment. What's the state of logistics within the U.S.? There's been a long-term trend for a while now that consumer behavior is driving growth in e-commerce, really over a decade. Not unrelated to kind of the short-term things that are going on, there are long-term trends like the technological capability of the consumer, being able to pull out a smartphone and hop onto an app and purchase items and on top of that, the expectation that comes with it, getting accustomed to receiving everything in a day or two because of Amazon. So there's kind of an Amazon effect happening, where everyone is growing accustomed to getting their things online and getting them very quickly. And once you have grown accustomed to these things, you tend to find more and more things that you can kind of automate within your life and get your dog food and get your furniture and and there's things like furniture specifically and clothing where the consumers are becoming more open to buying these things without seeing them first. They're buying products that in the past they would have gone to a retail store, put the shirt on, make sure it fits before buying it. But now e-commerce companies and retailers that sell online have solved that problem for the consumer as well with reverse logistics. So being able to ship someone a shirt and it's not too critical about what is the size is not correct, because you can send it right back and with no questions asked and get the right size shirt. And so the e-commerce companies and retailers that sell online are now kind of innovating in that space as well, and building infrastructure to handle reverse logistics, because it's becoming a large trend within the consumer behavior that they'll buy and try and then send it back if it doesn't work, and they would rather do that than come into a store and touch and feel the product when they can do that in the comfort of their home. So there's a long-term trend there in the consumer behavior that's driving e-commerce growth. And then really COVID-19, I think, has, while we're all at home and kind of reliant on the e-commerce companies to provide products to us at our doorstep, this has really increased the growth in the short term, but also increased the forecast for what growth is to come within e-commerce. So previously, our forecasts were in the 21% range of total retail, and now they're close to the 35% range by 2030. So we've had a tremendous short-term trend with COVID-19, where people are, in some instances, even required to figure out how to get things to their doorstep without leaving their homes. And that's kind of opened some eyes and created an expectation that in the future there will be this will accelerate the growth more than expected prior to COVID-19. So we see that e-commerce sales could even double again, potentially by as soon as 2025. So there's a very large growth in this space, and it's creating some infrastructure nightmares. As we grow, we're going to need more space within our fulfillment operations to keep up with that demand. And there's a record low in vacancies within industrial warehouse buildings today, and there's a record high in construction. So the U.S. alone will need to add 330 million square feet of warehouse space just for e-commerce, just to keep up with the growth that's expected by 2025. So we're running out of space. So and trying to figure out how we can keep up with demand in the short term as we're building more space. And how do we do more with less? And speaking of doing more with less, there's also a labor crisis going on right now. 60% of logistics operations say labor availability and retention is their number one challenge. Labor cost is growing, and it's already typically greater than 50% of the overall operational cost within a logistics company. And with the growing cost due to labor rates increasing, and also the lack of availability and retention in general, we're really struggling to fulfill some of the manual labor tasks that go on within a logistics operation. I think these are really seasonal jobs. They're really tough jobs. They're typically moving heavy objects throughout the day, and it's something that could be automated to improve the quality of life of our workforce, because that workforce is also aging. So we have a record low labor force participation rate, despite a record high unfilled job rate, and there's a lot of reasons for that. With the current situation with COVID and the stimulus packages, some can stay home and make more than they can by working. There's also the labor is aging, our overall workforce is aging, and the younger population is less open to doing some of these more manual tasks, these tough jobs, than the baby boomers that are kind of leaving the workforce over the next decade. So there's a situation that's not just a short-term problem, where the labor force participation rate in general is going to lower due to our aging workforce. So companies are facing increased demand from long-term and short-term trends in consumer behavior. Distribution and fulfillment centers need to increase productivity, but are constrained by space and labor availability. Companies are looking for new options to build a more resilient and effective means to fulfill their orders. And we think that robotics are really the key to expanding automation within logistics operations. A lot of these tasks that are these low-wage manual tasks have been difficult to automate in the past. But there are new trends within robotics and within perception and within software capabilities and intelligence capabilities for systems that are allowing those jobs to be done with robotics in the future. So why should we implement robotics now? One of the key reasons, just highlighted from the last few slides, is that we're struggling with supply chain continuity. We're struggling to keep up with the consumer demand, and really robots don't take breaks. Robots can work through the night. So there's really a continuity and a resiliency there where you can easily scale as your demand grows. Sustainability. In the past, robotic systems and really more traditional material handling systems utilized a lot of space. And I just spoke a little bit about how we're kind of running out of space. And humans don't take up too much space, but they're difficult to keep retained within your operation. Well, robotics and some of the new advancements within robotics allow us to do more within smaller footprints. So you think of collaborative robots in that way. You don't have to have the fencing. But also on like the depalletizing or palletizing side, it used to take very, very large systems to do that autonomously, and now those can be done with a robot moving a single box around instead of moving layers around, or having a big machine that does that for you. So you can really maximize your footprint there, relative to the means that you have with robotics. And then you're going back to the continuity piece a little bit, reducing the labor force dependency. So you can have longer operational uptime. Again, robots don't take breaks, and you can scale up quickly as your demand grows. You can scale up quickly as your demand flexes within a single year when you think of seasonal growth, or you can change focus quickly if your products are changing or your suppliers are changing their products. You can, with some of the advancements in perception and robotic systems, you can easily do more with a single robot than you can in the past without having to reprogram that robot. And also, as robots as a service becomes more readily available within the marketplace, you'll be able to quickly scale up and scale down within the seasonal swings of your business. And on top of some of these things, you get the added bonus of being able to track what's going on within your warehouse. You can track APIs. The data is there with the robot. It's not lost in translation as it sometimes is with labor force. It's really just a matter of setting up the right KPIs and pulling the right data into your business level systems. And overall, you'll also get the added bonus of increasing your workplace safety. So you'll reduce the interactions between humans and forklifts because you can now do a lot of those interactions with robots or even autonomous vehicles. and you will ultimately reduce the workplace injuries in general because you'll have less people doing manual tasks and moving large boxes around, for instance. So there's a lot of reasons to implement robotics now, and people are doing it, right? So the global logistics robot market is expected to reach 18.5 billion by 2026, and in the U.S., nearly 40% of warehouse and fulfillment centers already have some kind of robotic system. So it really, if you're just thinking of robots for the first time and you're managing a warehouse, you're kind of behind the curve at this point, and really need to get on with this trend in order to fulfill the expected growth that we see within the warehouse robotics market. We believe that robot arms need to take a bigger role, and that's also what the forecast says. The new capabilities will bring on new applications and allow robot arms to do more within logistics operations. So why haven't we installed robots up to date in the masses? Why do we not see robot arms in every warehouse across the country? And it comes back to what the traditional systems are capable of doing. Traditional robotic systems are more ideal for repetitive tasks. So they've permeated through automotive and process-related manufacturing because you're doing the same thing over and over again. You're doing something highly repeatable, which robots are very, very good at because of the control software. It becomes difficult to change what they're doing very, very quickly or in real time. You can pull out the teach pennant and tell it to make a new move. You can do some offline programming and or simulation and create a new application for that robot cell. But until the last few years, those things take time, and they take trained experts to do that. So there's another burden there on having experts that can do that. So they're when they are deployed and doing a repetitive task, the hardware itself is typically highly efficient, very reliable, very repeatable, and very good at doing the job. And that's why it's relied upon within most of our assembly line process related manufacturing. And one of this is a kind of a control issue. So this is something that really is changing and right before us. The capability of vision technology, the capability of software, and the processing hardware. Those three things are giving robots new capabilities. So you can kind of see there on the right, I threw something together from one of our vendors. There's this is only a few years part of technology. So up on the upper right is what a couple years ago a 3D vision sensor would have seen within the same scene, and you can just see with the naked eye just the huge difference, the variance that you have on the distinct edges, the coloration. You can really perceive with 3D vision today so much better than you can just a few years ago. So this is giving us that combined with more processing power and better software technology. Those three things combined are really giving robotics the ability to do more complex tasks like piece picking, like picking those objects out of that bin one at a time and really taking and doing that reliably, not just getting most of it, but getting all of it, or getting exactly what you're looking for, identifying these things based on a digital model. So that's really improving our performance in this complex task space. And then the software in general, there's a component of learning to it. There's a component of just the improvement of software in general to it, where over the air robotic systems are able to improve their performance after installation. So there's maybe this bit of fear of installing something today, and you know the new version comes out next week and it's much better. But really, these things are growing and improving over time, and you will benefit from them down the road as well. And in addition to that, how we program these robots is becoming easier and more automatic. So that's going to lower the costs as it becomes easier to do things, and hardware costs just naturally tend to go down over time. It's going to not only be less expensive, but also easier to deploy, so quicker to getting a solution on your floor, and quicker to adding value to your operations. So ultimately, there's new business cases within logistics becoming viable due to these capabilities and the decreased costs of more complex systems. So we're going to play a video for you here, just to highlight some of the use cases in kind of a simulation environment, a video of a simulation here. So really, there are solutions to interface with your material handling equipment, like your conveyors, your ASRS systems. So doing the picking of boxes and the pieces within the boxes, all of that can be automated within your operation. So there's piece picking here, where we're actually doing some order fulfillment. So we took the boxes off of the truck and opened them up and pulled the pieces out and put them into a tote and took them to the ASRS system, took them to some sort of automatic storage system, and then call those when orders come out and pull the product out of the tote and place it into the box, and pull different products and place them into that same box and create an order, which is then sent through an automated system to close the box and put the shipping label on the box, and then sends it to the palletizing stations, where you can build multiple orders onto one pallet. So just giving you kind of a high level idea of what's available out there for robotic systems. So let's talk about some of those in detail. So we'll highlight some Motoman solutions here. So Palletizing Solutions. Really, there's a kind of a movement of going to more multi-SKU palletizing, especially for things like grocery fulfillment, and sending things to like local retail stores or local distribution centers for e-commerce, building things to order on one pallet with mixed different cases is becoming a big topic. So we'll show you a video there. And Motoman solves this problem very well, because we have a packaging algorithm that can handle different types of containers and how to load them, and also how to load them into different destinations. So maybe you have some carts, maybe you have some pallets, maybe you have some AGVs, maybe you have some sort of automated material handling equipment that we need to interface with. It can handle all of this with the perception that it has. So real-time perception paired with the motion planning will allow for maximum performance. So you can get those boxes really, really close to each other because of the motion planning and the force torque sensing and the perception. So it allows for a really, really tight pack and maximum efficiency. So let's look at this case story from Paltech. Paltech was looking for a solution for palletizing a lot of different SKUs onto different types of containers. So they created some upstream automation, which would singulate the SKUs and store them. And then they would send all of the orders for the day to our controller. And then the controller would respond with how to send the packages for the most optimal pack of the pallet or the cart. So we're localizing the containers there, but also we're recognizing and localizing what type of destination is it. Is it a cart? Is it a pallet? We're using our auto packing algorithm to pack with maximum efficiency. And you kind of get an idea of what that digital twin looks like in the background, and that's how we do the no-code deployment with that real-time motion planning. Let's take a look at another interesting application here. We see that there is, especially in Asia, and they're really emerging here in the US now, is a larger need for automated vehicles, especially within micro fulfillment centers. Where there's not a very tall storage capability. AGVs and AMRs are becoming a necessary and highly capable means of storing dynamic stock and fulfilling orders as well. So here's a palletizing operation onto the AGVs. So you can essentially pull in the boxes from the trucks and then palletize them into storage on top of mobile vehicles, and then bring them to another cell on the other side of the facility to fulfill those orders onto vehicles and take them to the truck. So all of the material flow within the dock bay doors is handled by some conveyor, but then mostly the AGV vehicles. Greg, I think this video is a bit long, so you can skip to the next one. Okay. Looks like the title got messed up there, but that says Depalletizing Solutions. So moving on from palletizing and into depalletizing. So here we can do both single SKU depalletizing and mixed SKU depalletizing. If you're going to build a mixed pallet, you also have to be able to break down a mixed pallet. So this is a very high value application, and also something that needs a lot of technology behind it. If you don't know anything about what's coming into the work cell on the pallet, then you need to be able to recognize it, and register it in real time. So that's what our system does. It uses force torque sensing, it uses 3D vision, and it actually auto registers the boxes as they come in with their length, width, height, weight, and all of that data can be shared to the downstream automation for whatever purpose. So it allows us to handle multiple SKUs and SKUs that we've never seen before. So this is a quick video of the multi-SKU depalletizing. So it's masterless. There's no external data about the boxes that are coming in. So we are managing to pick and drop this onto a conveyor in real time with no prior information about what this pallet looks like. We're using a 3D vision sensor, and we are looking at the top of those products to determine what the layer looks like. And then as we're picking, we're using force torque sensing to find the center of gravity and the weight based on what we think the length and the width is, and also determining the height along the way, and registering that with its barcode data. As we get close to the conveyor, there's a barcode scanner down there. So we're essentially creating a registry of all of the boxes, all the different SKUs that are coming in. And one of the things you have to account for when you create intelligent systems is some of the outlier situations, and vision sensors aren't perfect, and you need to have secondary measures to deal with different situations. So this video does a great job of highlighting that. There's actually kind of a vision system error here, where it thinks this box that it's about to pick, it thought that it was 2 boxes. So it goes and tries to pick where it thought there was a single box, or one of the 2 boxes, when there was actually a bigger box. But it quickly realizes when it lifts that, hey, that center of gravity doesn't match up to what I expected through the force torque sensor, and it adjusts and picks the box in real time, creates a new plan, picks the box in real time, and grabs it. and takes it to the conveyor. And then in the future, you won't have that problem because you've registered that data, and it should have a better idea of what that looks like. So it's in a sense learning what these SKUs are, registering them, so that in the future it can do it much more quickly. So by building these capabilities into the system itself, you have a lot less downtime, and it's a much more flexible system because you can send different boxes in here with that. As long as the robot and the gripper are physically capable of picking it up, the system should figure it out. You can go ahead and go to the next one, Greg. And then in this video, this is kind of an internal showcase, actually. So that system that we just showed was as we are registering and seeing the objects for the very first time. We can typically get somewhere, but depending on how big the move is and how much they weigh, because you'll notice that the robot is adjusting its movements for the weight in real time as well. You can typically do somewhere between 400 and 800 cases an hour on new systems where we don't know anything about the SKUs. But then as the system registers more and more SKUs and gets better at finding it on the very first time and identifying it and sending the robot with purpose directly to where it's going to go every single time, then you can actually get up to 900 to 1,000 cases per hour with a pretty, if you have a pretty short move there. So the efficiency, the performance is pretty high, but also the efficiency is very high. And on these types of systems, we tend to see some need for human intervention, and usually it's below 1 in 10,000 picks. You'll also notice that some of these SKUs are kind of flat and maybe shorter in height, but longer in the width or the length direction. And you'll see here that the robot actually accounts for that. So it knows it has a less of a gripping surface, but it feels the weight and knows the height of that object, and it adjusts its speed and acceleration in real time so that it doesn't lose vacuum on these objects. So that comes back to this physics engine, this digital twin that's in the background, where we have everything in this space modeled not just with its geometry, but also with the physics behind each component and the mechanics behind each component. And then we showed some AGVs on the palletizing side, so wanted to highlight this one as well. So this is actually at IREX in 2019. We did a showcase with AGV systems and doing a depalletizing operation, and also you'll notice the multi-picking. So we developed a gripper that can actually do multi-picks and then singulate for the material handling equipment, so that we can then have less costly and also minimize our footprint on the conveyors by letting the robot do the singulation of these boxes. So we're communicating to the AGVs to tell them, when to move in and when to move out, and what items the system downstream is going to need. So all of that communication between the AGVs and the robotic system can be done by the motion controller. And you'll notice that it's picking up in kind of many different orientations. It's taking what's there as it's being presented, and then creating a motion plan in real time to account for that. Okay, moving on from the palletizing and depalletizing, let's look at some piece picking solutions. So piece picking is essentially picking the different products, whether that's directly from the box as it's coming in from a supplier, whether it's from a tote out of a storage system and into a box to build an order, or whether it's just doing some container switching to reorder the different products within the storage. This is a very difficult problem, and one that has been there. Many have tried to solve it for the last few years, and we have a really great solution for this problem. And there's many different forms of this, and you'll see that in some of the videos. But essentially, we create a digital replica of each workpiece, and we can do that with an automatic robot cell, or we can do that manually, depending on how many SKUs you have in your system. And by creating that digital replica, we can then create grasping techniques in our kinematics algorithm. And then using the perception and force torque sensing, we can confirm that those grasping techniques work on the products, and also using that force torque sensing, we can prevent any damage because we know how big the products are, because we've created a digital replica. We have we know when we have grasped it, and we know when we've grasped more than one object as well. And that way we know exactly how it's oriented on the gripper so that it doesn't create any damage, but also it allows us to pack really, really tightly compared to others in this space. So we create really efficient packs. We can do that on our own with our packing algorithm, or you can tell us exactly how you want it packed. You can also add some auxiliary pieces. You can do some confirmation scanning, some in-the-air barcode scanning, and you can also add label applicators. We've also, you'll see in one of these videos as well, that we've even picked up the order sheet off of a printer and threw it into the shipper box, so that when the box is closed downstream, it has the order confirmation note inside the and the pack list inside the box. So there's a lot of features in this solution, and something that really adds a lot of value in order fulfillment processing. So this is actually for Hitachi. And you'll notice that we are picking the products. It's mostly small boxes. We're actually scanning multiple barcodes on each face of the product. And we know where those barcodes are because, again, we've created a digital replica, so we can very precisely go to the right position to scan that barcode without having to do too much trial and error. And then on the packaging side, it's getting very close to the next piece, and we're creating a really nice, tight package into the tote so that we can maximize efficiency, storage efficiency. Additionally, as things change, the vision system is looking at the destination tote, so it will recognize if a box falls over, and it will package the next one appropriately to accommodate for that. If something somehow even does happen in between, snapshots of the vision system with one of the products in the destination side, the force torque sensor will stop product damage as kind of a redundant system. So this is one of those things that, coming out of Japan and having very high expectations for how to manage products. We've done a lot of pharmaceutical work in Japan as well. We're very good at ensuring that we don't damage your products as we're moving them around. And this is our last video here before we wrap up. This is Uniqlo. This is fast retailing, and they're looking for a solution to replace the operator at their order fulfillment station within their ASRS. So you'll kind of see the story here within the video. So a lot to digest there. The system is moving boxes around, the system is moving polybags around. It's doing some RFID sensing on that table that was going in between them to confirm that it was the right product, and to kind of have a redundant scenario there. Yeah, and then also picking up the order sheet at the end before the ASRS system takes the box. So I see some questions coming through here, and that's where we'll go here. So just again, want to thank Yaskawa, thank you, Greg, and the entire marketing team for hosting us here. Looking forward to answering some of these questions.
The first question is, why the handoff of the product to the other robot at the beginning of that video?
Yeah, if you notice, there was actually two different grippers. So for more for efficiency, we do have tool changers where we could switch hands on a single gripper. But when you have polybags and other equipment, and then also it was grabbing the order sheet as well with one robot, just having some versatility within the cell for the different types of material, different types of products that it was gonna see.
Kashal is also asking if you have a similar application picking shafts or motors from a bin, so heavier parts, I guess.
Absolutely. So that's I didn't really talk too much about our factory automation division. This webinar has been focused on the logistics side, but we do offer factory automation solutions, primarily bin picking, exactly what you're talking about, I believe, Kashal. So we have a lot of videos on our website and on YouTube. If you email me, Kashal, I can send some to you. But we do a lot of bin picking, and we're really good at bin picking and getting to the bottom of the tote, and that's a great application for us.
Well, if anybody else has any questions, now's the time. Okay, seeing no further questions, I guess we'll go ahead and shut it down. Just a quick reminder that you can replay today's presentation as well as past webinars on our website, motoman.com. Go to the About menu and then Webinars. Usually takes a couple hours for this webinar to appear on the list. You also receive an email with a link to the video replay of today's presentation. We hope to see you again at our next webinar on September 23rd. The subject is the importance of investing in training. As always, thanks for spending part of your day with us, and we want to thank Josh for presenting today, and have a great show season, and we'll see everybody in a couple weeks. Thanks, everyone.